This is a demonstration on how to use motor drivers to control motors. First, we'll control this motor, and then we'll control another motor later. And in this case, the motor, this is the motor, this is the gear. So this is a gear motor. Same with the second motor later. But as of this moment, we'll use this. This is rated 6 volts, 3 to 6 volts. So it needs 3 volts for it to turn or to work, and maximum of 6 volts. Beyond 6 volts will be dangerous. It might burn the motor. And then this motor driver is capable of controlling two motors. So this is the first and this is the second. We'll just use this one to control this one. And you have 6 connections. This is for the power or VCC. This is for ground. And then this is to control this one, this pin is to control the amount of power that goes into this terminal. And the other pin controls the amount of power that goes into the other terminal. So this is positive, negative, or this can change. The polarity can change. This can be positive or negative depending on the direction of the flow of current. So currently we have connected 2 pins that controls the gate for 2 terminals to pins number 5 and 9. Remember that 5 and 9 are PWM pins. And using PWM pins, we can actually generate analog signals digitally. Okay, so since the power will be coming from a separate power supply, so we use a battery. The amount of power that comes from this battery is 8.4 volts maximum voltage, and the microcontroller will be powered by the computer's USB port. So we need to ground the two for them to be able to communicate. So 4 is ground. This is ground 1, 2, 3, 4. That is ground. And then I'll connect this to this. Okay, so they are now grounded. And I'm going to connect power to these pins. So I'll use my DIY connector. There. So this is just a temporary connection. So after I plug this in, this should light up. Okay, so there's power coming from the battery, and here in the code, I'm not going to power up the microcontroller, not yet. So let's check first the code. So here I have 2 pins, 5 and 9. So 5, so this is 5, this is 9, and then same with the robot. I have set both of them to output, and then in the first set of statements here, so this is for forward, so I'm going to send 1 to 8. Maximum is 255, 255 being 100%, so 1 half of 255 is 1 to 8. So half of the time the signal is on, half of the time the signal is off. So I'll be sending, so that will create an analog signal, which is 2 8.5 volts because this is a 5-volt system. So the signal, a full signal is 5, so that's high. An analog signal, which is 128 over 255, is actually 1.5, around 2.5 volts. Okay, so I'm not going to send the entire 5 volts or I will not send a full high signal for 5 volts, so that half the time the gate will be open and half the time the gate will be closed, allowing only one half of the power from this battery. So the uh, full charge is 8.4, so around 4.2 volts will be sent to this motor instead. Okay, and then for the second pin, I'll be setting it to 0. So 0 over 255. So 100% of the time, the gate will be closed. So this will not get any power. So this will be our negative. So power will flow here and return to this terminal. Okay, and then this will basically close both gates, or basically you can say that we're telling the motor driver to shut down all power to both terminals, and then wait for 2 seconds and then reverse the flow so that it will move the other way, and wait for 2 seconds and then stop, and then wait for 2 seconds and then everything happens over and over. Okay. So I have uploaded it ahead of time, so let's check. Forward, stop, and then reverse, and then forward, and then stop, and then reverse. There. Okay, as simple as that. So if I will specify here 255, for forward it will use 100%, which is dangerous because this is 8.4. Maybe let's make it 60%, around 150 or 153 over 255. So this should be faster when moving forward. So I'll upload. So faster. Reverse is a little bit slower. Maybe let's increase it to 200 over 255 so that the speed will be noticeable. Upload. Okay, so just a lot faster. And then reverse is slow. I'll return it back to 128. Okay, so I'll switch this off and let's try using the other motor and the other motor driver. So what is nice about this motor driver is it can control 2 motors at the same time, which is enough for our mini robot. But if you are going to assemble a bigger robot, of course you'll be needing bigger components, bigger motor, and of course a bigger motor will require that you use a bigger or better motor driver, and also a bigger or better power supply. So I'll remove this and remove this and try the other motor. Okay, this one is a lot bigger. It's a lot bigger, and this motor driver can can deploy motors. This is a 12-volt motor. Okay, 12-volt motor. And then this motor driver can control motors. 12, I think around 5 volts up to 27 volts or more. So I just have to check the details for the manual. And this one can only control one motor. So to control 2 motors, you need 2 of these. So what will be the connection? Based on the manual, I need to connect this pins number 5 and 9, same. Okay, same. So let me just check. This is 5 and this is 9. Okay, so same connection. Same. So this is for the power supply. This one is for the power supply. And this is for power. This is for 5 volts, and then this is for ground. And the power should come from the microcontroller. So probably I'll move this here and set this rail for the power. So I'll just connect ground over here. So I have ground here. Just ground. I'll connect it over there. Just ground. And to get 5 volts, 5 volts is here. 5 volts. 8 volts. That's 5 volts. I'll connect it to this power rail. Alright. So let's double check the connections. So this becomes 5 volts, the entire row, and this becomes ground. This is connected to pin 5, and this is connected to pin 9. So I'll connect this to ground. So this is ground. Okay, that's ground. And this will be connected to 5 volts. That's 5 volts. Excuse me. Okay. This is the power, this motor driver for communication between the two. Okay, so this will be 5 volts ground, and this motor driver has a safety feature for this to work, for this pin to work, and for this pin to work, you need to send digital signals to these 2 pins. And this is very useful if you need to shut down the motor for emergency reasons. But as of this moment, I'll basically just connect this to 5 volts because a digital signal is basically 5 volts. So I'll connect it to 5 volts. Because if you do not send digital signals to these 2 pins, these connections will be disabled. Okay, how about this? This is to check for overcurrent. So if everything's okay, the signal will be set to 1. mean, if everything's okay, the signal will be 0. If there's something wrong, then it will be set to 1. So 1 is, we can actually connect this to the analog pins A0 and A1. So hold on, I'll connect it to A0 and A1 and use them as digital pins, A0 and A1. So the code will be the same. Okay. So this can actually be optional, but if you would like to use these pins, check for problems, you can just add them here. Launch in say emergency pin 1 is equal to A0 or 14, no, also known as A0, and emergency pin number 2 is equal to 15, which is equal to A1, and they will be set for input 2, 1, and E2. And then you can just add this statement. So this is a loop. So everything will be done over and over again. But if digital read E1 is equal to 1, or digital read E2 is equal to 1. So whichever becomes 2, what will happen is we'll set both to stop. Okay. So set both pins to stop 0. Or if these pins are connected to these connections are connected to a different pin, which we can control, we can actually set the equal to 0. So whichever works. So in this case, we'll manually change the signal being sent to the pins 5 and 9 if something goes wrong, and we would know if those pins sends a digital signal. Okay, but in this case, we are really not concerned about that because this is just a simple demo. Okay, so there is no need to ground the two because the power is coming from the microcontroller. Okay, I'll connect the power. So this is coming from an AC to DC wall adapter. So this is 12 volts. Power coming from this is 12 volts up to 2 amps. So which is enough to run this motor. So I'll connect, and then I will upload. So I'll connect and upload. It's actually running, but let me just upload the code. So same thing. So this will be forward. So forward and then reverse. Forward reverse. Let's move this forward so you can see the motor. There. So same code with some changes depending on the features of the motor driver. But basically, we will use the same code. All we need to do is to just read the manual of the motor driver, make sure the two can work together, and then for the microcontroller, it's as simple as sending a signal. And you have a small robot because that's easier to control and easier to manage, especially when it comes to using power. So for the robot, you can just use a simple power supply, battery. But for bigger motors or bigger robots, you will need a bigger power supply to control the motor. And that's it. Thank you.